Starting at age 20, Pete decides to invest $300 at the end of each month in an IRA with an APR of 4.5% compounded monthly. So I haven't underlined anything yet, and it's driving me crazy, so I'm going to come back and do it. That 300 was important. End of each month tells me probably we're not going to have interest on that final payment. In an IRA, that's great. APR of 4.5%, I need that. And compounded monthly, that tells me my end. And then how much money will be in Pete's retirement account when he retires at the age of 62. Assume his last deposit generates no interest. So we don't have very much information. We do know that there's no interest, so the L is just going to be the P. But we need to look when he retires at 62, so we're going to subtract 20, and so he'll be making deposits for 42 years, so our little t is 42, and the big P, it looks like, is 300. That's how much money he'll be depositing each time. His rate is 4.5%, so 0.045, and compounded monthly, so his N is 12. And then we need to find our capital T and our little p. So our capital T is NT. We know N is 12 and T is 42. So when I multiply those, I get 504. So that's how many payments he's going to make over his lifetime. 504 payments. The little p is the R over N. So the R is 0.045 and the N is 12. So we'll divide that one, 0.045 divided by 12, and I get 0.00375. Now I thought I should switch calculators so you can see it with a different calculator, store and recall. So I'll show you on this calculator next. So this one we need to still write in. I should do this 0.045 divided by 12, and I get that 0.00375. So that's my little p, and then now I think I'm ready to write my formula. So I have big F equals, it should be L, but I know I just need the capital P, and then times the quantity 1 plus little p to the capital T minus 1 over little p. Fill in some of the values. F equals my big P, there it is 300. 1 plus little p is 0.00375, raised to the capital T, which was 504, minus 1, all over the 0.00375. All right, this calculator is not quite as easy to see what you're doing with your store and recall, so I'll show it to you, but you have to kind of trust that it's stored things, and you can find out when you do the recall for sure, but sometimes that's too late. But for this one I want to store, so I'm looking for the STO button again, so I just do store, and then I tell it a digit like 1 to 6 or something I think you can use, and so I type 1, and it doesn't really do anything, but it stored it in 1. So I know that one is stored in the 1 bin, and so I can use that when I go to divide later. So I have 1 plus that 0.00375, so the 0.00375 is sitting on my calculator, so I'll just do plus 1 equals, and now I have 1.00375, that's perfect. Raise it to the to the button on this calculator is y to the x, so the to the 504 equals, so that's my part of the numerator there. It's this part I did the plus 1 and then to the 504, so I've done all of this. Now I need to subtract 1, so we'll say minus 1 equals, and that gives me now this whole this whole numerator here, so I just need to divide by that 0.00375. So I'm going to divide by and then do recall. It has its own button on this calculator, so recall, and I push 1 because that's what I pushed before, and now you finally see, oh, it had it. It stored my number, and then push equals. And now I have this whole big parentheses part, and I just need to multiply by the 300, so times 300 equals, and I finally have my F. So for this problem, F equals $, and this one's hard for me to see those decimal places. There it is after the 0. So 44768 point, and it's 8, but I look at the next digit, which is a 6, so I know I have to bump it up to 9, so it's now going to be 0.89. So count over 1, 2, 3, put your comma in, and I can say Pete will have $447,680, 440, I keep saying that wrong. Pete will have $447,680.89 in 42 years. Not a bad nest egg.